Okay, this video is on quadratic sequences. You see at junior cert level and at leaving cert level, and there's a specific type of sequence which there's a special way of dealing with. So we're used to sequences which are patterns and numbers, and we spot this pattern as it progresses. So, but for a quadratic sequence, we have to try and make it fit into this pattern here, or find the A, B, and C such that this works. Now, how do we know a sequence is quadratic? Well, to find any sequence, such as say 2, 4, 6, 8, we know that's a sequence where the next term is 10 because it differs by 2. But if we look for the pattern here, it's a little bit more difficult. So for instance, what's the difference between 3 and 8? Well, that's an up 5. 8 to 15, well, that's up 7. 15 to 24, well, that's up 9. So no definite pattern emerges in what we called the first difference. Okay? So this is our first difference. So let's go again to the next layer and see what's the difference between 5 and 7. Well, that is 2. 7 and 9, and that is 2. And as this sequence went on, we would have seen that the second difference was actually the thing that was constant. So once we have a second difference, that's what we're looking for. A constant second difference, the same number each time. So we saw our first difference, we couldn't spot the pattern. We went to second difference, we saw there was a pattern too. Now, we need to make a small little equation or formula up for this specific quadratic sequence so I can tell you what each term is. Now, what I do want to remind you of is that when we talk about terms, we're talking about TNs. This is the first term, which we call T1. This is the second term, which we call T2, the third term, and so on. And by finding this TN formula, we are finding a formula for any term. So for instance, we could find the 100th term without having to write out all of this to get back up to what the 100th term would be. We can literally figure out a formula for any term on this using this. All we need to do is find the A, B, and C. But a key piece of information is, when you do find that second difference, the A term here, well, that's half of that second difference. So for us, since the second difference is 2, half of that second difference is A. That implies that A must be equal to half of 2. So A must be equal to 1. So we actually know the first term straight away. So what do we know so far? Well, we'd figured out now that A is 1. So since we know A is 1, well, that would imply then that Tn here, instead of, we can put in what we have for A, which is just 1, times n squared plus bn plus c. And of course 1 times n squared doesn't do anything, so Tn effectively is equal to just n squared plus bn plus c. So this is what we know. But how do we figure out b and c? That's the next big part for this, right? Well, for b and c, there's some information we can use. To find any term, we replace n by the term we're looking for. So for instance, if I wanted to find the first term, I'd replace n by 1. So what's the first term? Well, the formula would say t1 is equal to, and let's replace all the n's by 1, 1 squared plus b times 1 plus c. And that would, if we knew b and c, that would give us the first term. But we do actually know the first term. This stuff should equal to 3 because the first term is 3. So actually from that, we can do a little bit of tidying up here on this section. 1 squared is 1. B times 1 is just b. And of course, c is equal to 3. I can now make an equation in 2 variables as b plus c. 1 comes over as a minus. 3 minus 1, 2. So I actually have this equation now. B plus c is 2. Similarly, I can do that for term 2. So to find the second term, it says I replace all the n's by 2. That means it's 2 squared plus b times 2 plus c. But of course I know the second term, it's 8. So 2 squared, that's 4, plus 2b plus c equals to 8. 4 comes across, becomes a minus, so I left with 2b plus c is equal to 8. Now minus 4, which is 4. Now yeah, I could do this for the 4 terms I see here, but I don't need to. I'm looking to figure out b and c. They are 2 variables. How many equations do we need for 2 variables? Well, we need 2 equations, which we have. So we are going to solve these simultaneously. So what I'm going to do is, I'm going to move this guy over underneath here. 2b plus c equals to 4. I will simultaneously solve him by first off, I will change all the signs here. So change him to a minus, change him to a minus, and him to a minus. And let's draw the line. So b minus 2b now. That's a minus b, c minus c. They cancel. That's what I was looking for in simultaneous equations. And 2 minus 4, that's minus 2. So if minus b is equal to minus 2, that means b must be equal to 2 if I change the signs across. So I now have b is equal to 2. How do I figure out a? Well, I can take either one of these equations. I'll take the easiest one, b plus c is equal to 2. And I say, since b plus c is equal to 2, then 2 plus c, because b now becomes 2, is equal to 2. He comes across as a minus, therefore c is equal to 2 minus 2, which is 0. So, now I know b is equal to 2, I know c is equal to 0. I knew when I had a is equal to 1, I could simplify to this. So therefore, given all that information, I can then say that the general form for this sequence is Tn is equal to, yes, n squared. Now b gets replaced by 2 plus 2n. And since c is 0, there's no point in putting in, it's gone. So any term in this sequence is given by this. So now we may be asked in a similar question, well, maybe find a certain term in that sequence. So I'll try and maybe squeeze it in on this page here. Let's remember our pattern here. Our pattern goes like so on, so on, so on. So what would the next pattern be? Well, look, if that goes up 5, up 7, up 9, the next difference should be 11, shouldn't it, over here? Because they're difference by 2 each time. We know from the second difference here. So what's 24 plus 11? So it tells us the next term should be 35. But what would the next term be? Well, if I have the first, second, third, and fourth, that next term there should be T5. So let's show you how to use T5. So we know that the term 5 should be equal to 35. We just kind of worked that out in our heads. But let's actually go with the formula we have to find term 5. So term 5 is equal to, well, here's the form for any term in this sequence. Term 5 is equal to 5 squared plus 2 times 5. So 5 squared is 25, 2 times 5 is 10, 25 and 10, yep, 35. And that is how you use quadratic sequences.